Hello again. So in this video I'm going to do a derivation, and I'll do another derivation in the following video. So here we have a pretty complicated two sentences. So here our conclusion is P if and only if R, if that, then Q only if S. So we'll make a standard setup conditional assumption, we'll show the consequent, we'll make a conditional assumption, and we'll show the consequent again and make an indirect assumption. So there we have that. Now we, and I'm going to bring down 2 and 4 just so we have them all next to each other, as well as the premise. So doesn't look very good. We can't do much with the biconditional on line 7 or the biconditional on line 9. So we're going to need to do a subderivation because we're stuck. And there's no unneg subderivation to be done. So we need to do a subderivation that will allow us to use line 7 or 9. And we'll do a subderivation to set up line 9, because in the process of making assumptions we may be able to get to a point where we'll be able to work with line 7 as well. So 9's more complex, so we're going to do a subderivation with it first. So we'll say, with the show and command, we can let us show either of them, so we'll just pick P if and only if Q, because why not? Now, how do we show a biconditional? Well, we show the component conditionals. So we're going to show if P then Q. Now note, if we're paying attention, Q is what we need to box and cancel, and we have Q, so we can already box and cancel this derivation. That's nice. That was easy. And now I want to show the other conditional. So we want to show if Q, then P. We already have Q, so this assumption doesn't really help us, unfortunately. So we get to not P. Now we want to see if we can use not P with any of the other material that we have. In fact, we can. We can use it with line 7. We can do, if the left-hand side of 7 is false, if this says they have the same truth value, so if this is false, then that's false. And this is false, given line 17. So this is also false. This is also false. So we can apply BP, one of the derived rules. You could do BC and then modus tollens. And we get not R. Now at this point, doesn't look like we can get further. So we might try showing the other part of 9. So we can say show ant 9, the other antecedent, the other component. So we want to get if R then S. And if we're paying attention, we note, oh, well, R, we already have not R, so we can bring that down for an indirect derivation. Hold on just a second. Okay, so here we are trying to show if R then S, and we notice that we showed if R then S, excuse me, I got interrupted. So now we need to show the other conditional if S then R. And we'll say assume CD for S, and we can see, oh, we have not S up on line 6, so we have an indirect derivation. And we get a conditional or biconditional, which is a direct derivation. So we get R if R then S, and that will let us do, we can then use, we got this because it's part of line 9. So we can say 19.9 and then BP again, and that gives us P if and only if Q. Now that's what we were trying to show up here, but in particular that's also what we're trying to show right now is P, and we can use Q with Q if and only if P to get P. So now we have P, and that gives us, that's the consequent of if Q then P. So now we can put these two conditionals together and get P if and only if Q, which is what we wanted to show. And now at last, we can use P if and only if Q with R if and only if S. So we can say 9, 10 BP. We have not S. We can use that with 36 to get not R. So we'll say 636 BP, and we have not R. Now at this point, let's see. There's more we can do. We can use not R to get not P. So we can say 737 BP because we have P if and only if R, and we have not R. Lots of BPs. So here we have not P. Then we have Q. So we think, well, what are we going to do now? We've used line 2 because we repeated it, and we've used line 7. Q, we've used a bunch. Not S, we've used a bunch. This is just a repetition of line 2, which we saw. Q we used. This we've used. We broke it up. We got if R then S. This we used. We used these two together to get R if and only if S. And now we have not R, not P. What are we going to do? Well, what are we going to do? You might want to think about it for a second. You can pause the video and look and see. I'm going to go ahead and say, so this biconditional here, P if and only if Q, we did a subderivation of it so that we could break this biconditional apart. But we can also use this biconditional as a biconditional and break it apart as well. And in particular, with line 8, right, we have one side of it, and so 8 and 10 together tell us that we have P, and that's a contradiction. We have an indirect derivation with 38 and 39. The thing to notice here, and this may have happened a little bit before, it happened at the end of chapter 1 some and will continue to happen, is that you can use a sentence in more than one way. Right? You can use P if and only if Q as to break this apart to get R if and only if S. But if you have P or Q, or not P or not Q, you can also use this to get whatever. If you have P to get Q, if you have Q to get P, if you have not P to get not Q, you can get not P. But the point is you can use this in two ways. You can use it as to break up as part of breaking up something more complex, but you can also break it up. And that double usage is something you want to pay attention for. So in any case, we have P and not P, which is an indirect derivation. So we have 5, which is the consequent of line 3. And 3 is the consequent of line 1. And we are done with our derivation. So good. I'll do another derivation in another video.